Hello students, in my last class, we have discussed Parseval's theorems. And Parseval's theorem says that if you know the Fourier series of a function, then you can calculate the RMS value of that function using the values of Fourier coefficients. And further, if you know the Fourier series, then using the Parseval's theorem, you can also find the sum of many or very important infinite series. Let us understand this with an example. So say I have a function, I'm taking a simple function, say fx is equal to x, and this is defined in the interval pi x pi. Now I want to write the Fourier series of this function. So let us first write the Fourier series quickly. This is the odd function. So we know whenever the function is odd, your cos terms will be zero. So your Fourier series for this function will be summation n equal to 1 to infinite bn sine of nx, because the interval is 2 pi. And now we know how to find the bn's value. Bn's values are given 1 by pi minus pi to pi. Function is x sine nx dx. And this gives me the bn value 1 upon pi. If I integrate this one, this will give me cos of nx upon n. And of course, there will be minus, and then you have plus sine of nx upon n square, because I'm doing with by parts. And then you can put the limit here because this is the odd even function, so you can write this is 2 by pi 0 to pi x sine nx dx. So let me put the limit 0 to pi and multiply here with 2. So this gives me 2 by pi, and then you have a pi, you put here pi, cos n pi is minus 1 power n, then you have a n, sine n pi 0, put 0 here, 0, 0, everything 0. So you have a bn. So my series becomes n equal to 1 to infinite, and my pi cancels here. So my series is minus 2 upon n minus 1 upon n. So this is a simple expression. Now I can write the Parseval's theorem. Okay, so Parseval's theorem says I have minus 2 upon n, 1 minus n. So my series is, I'm writing it here again, summation n equal to 1 to infinite minus 2 minus 1 power n upon n minus 2 power minus 1 power n upon n. This is my say series. And now Parseval's theorem says that if I take the square of the function, average of the square of this function, f squared dx from minus pi to pi, and then you have a interval 2 pi, this should be equal to summation of bn square, only bn square, because an square, of course half will be there, a naught is 0, because for series here the actual expression is a naught square by 2 plus uh, half of an square bn square. But an square is 0, so I'm only writing the bn square. Again 2 will also cancel. So now fx square is minus pi to pi 1 upon pi. Fx is x. Fx is x. So this would be x square dx. And here bn square means bn square. So you have here 2 to 4 and minus 1. This will be only, of course, function is sine nx is there, nx is there, 4, and this will be 4 upon n square summation n equal to 1 to infinite. Bn square, I'm only taking coefficient, this coefficient. So now if I solve this one, pi x cube by 3, 2 pi 2 pi by pi cube by 3 and minus pi cube by 3. This gives me 2 pi cube by 3, and then you have 4 1 upon n square, n equal to 1 infinite. Okay, and this gives me pi square, and this 1 2, so this is pi square 6. So summation 1 upon n square is pi square 6. This is n equal to 1 to infinity. Okay, now this is what, this is series n equal to 1 to infinity. 1 upon n square is what? This is the 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square, 1 upon 4 square, so on. And this value is pi square by 6. Similarly, I can find the value of terms containing only, I multiply this by 1 by 4. So 2 go inside. So now this will be equal to, I multiply by 1 by 4, so this become pi square by 24. And this is equal to, now only if you put n equal to 1, you get only even terms. 2 square plus 4 square plus 6 square. So similarly, if I want to find the series for only odd numbers, so what I can do, I can write here 2n minus 1 square. Now this will be this minus this, okay? Because this is a complete series. This is the even numbers. I want to remove these even numbers. I want only odd numbers. So this will be n1 infinite 1 upon n square minus n equal to 1 infinite 2n 1 upon 2n square, and this gives me pi square 6 minus pi square 24. And if I solve this one, what will come? If I take, say, 24 LCM, so what will come? 24 will give me here 4 pi 3 pi, so 3 pi square upon 24, which is equal to pi square by 8. Okay, this will be pi square by 8, 24, 4 pi square minus 3 pi square, so 20 pi square by 8. So here we have seen, using the Parseval's theorem, we can find the sum of infinite series. So we'll continue with the Parseval theorem in my next class also. So I'm stopping here. I will see some more good examples. Thank you very much.